How are you, my friends? This video is presenting the third 10 questions of the 30 all the exams review questions that will cover lectures 24 to 30. From other types of equations like quadratic in type and radicals until linear functions. Let's see question number 21. Find the number of the solutions of this equation. Clearly, since we have this equation is equal to 0, we have to factor it. So from lecture 12, if you want to go and see the factoring in rational exponents like this, factor out the least power. Where's the least power here? Half, 3 over 2, 5 over 2. So the least power is half. Now use this idea. If you take, see, there is no number in the common 4, 5, and 1. So we take x plus 1 all to the power half. Let me show you what we do in lecture 12. So take this out. And now this is the given power. This is the given power minus the power outside. So half minus half. Half is the outside. 3 over 2 is the given power minus the power outside. Because when you divide, you subtract here. 5 over 2 minus the half. Let's see what we do here. Leave this one outside. X plus 1 to the power half minus half is 0. X power 0 is 1. See, this is only 4 times 1. 3 over 2 minus half. This will be 3 minus 1. 2 over 2, which is 1. So we just take the 1 out. Now, 5 over 2 minus half. 5 minus 2, 4 over squared. So this is x plus 1 squared. Now that's the equation. So what do? We expand inside now here. We have to add all this. Remember the formula, x squared plus 2x plus 1. Factor more, and then we continue in the next slide. So we expand this first. Then we add everything until we get x squared minus 3x. See, 4, 1, 5 minus 5, 0. So this is x squared minus 3x. This one, x plus 1 power half, will be the square root of x plus 1. And take x out here, common factor, x minus 3. Each one is equal to 0. So we have the solutions minus 1, 0, and 3. So we have 3 solutions, 1, 2, 3. If t is the solution of this inequality, and L is the solution of this inequality, find T intersection L. See, this is absolute value inequality. So that's algebra course number 26. Yeah, I wrote it here, 26, you can see. Take the first one, we rearrange it. It looks like case 3. See, case 3, we have absolute value greater than 4. So we have to take the expression less than minus 4, or 2 minus x greater than or equal to 4. Solve this one, solve this one. So we get x less than minus 2. Here we can change the sign also and multiply with the minus. Make sure you get all these numbers. So minus infinity to minus 2, you draw it there. Union 6 here, 6 to infinity. Now, absolute value x minus 1 less than 5. This is case number 2. I wrote here case number 2 from lecture 26. So x minus 1 between minus 5 and 5. You add 1, etc. Then you have to draw it from minus 4 until 6. Now we need the intersection. See, in the question we said, find T intersection L. So here only one number in the intersection. That's a tricky part. One number in the intersection. That's 6. Here we have an interval from minus 4 to minus 2 closed. Now in this question, we need to graph this piecewise function, 3 pieces. And then after we graph it, we answer the question where the graph is above the x-axis, and we need to find the domain and range. Remember, graphing piecewise functions, we have 2 pieces, sometimes 3, 2, 4, etc. This is, I have done that in lecture 28 in the algebra course. I take piece by piece. So I will show you here in details. What do I do? I take the first piece. You know f of x is y. So y is equal minus 2x between minus 3 and minus 2. That's the condition. See, I start with minus 3, put it there, you get 6. So I put the point here. Then I take minus 2. It will be 4. But remember, this point is open because we have no equal. We stop, that's it. Part of the line. We know this is a big line from minus infinity to plus infinity. But we have a condition on the x. Remember, condition on the x. So this line is only between minus 3, minus 2, only this line. Close there, open there, all the points between them. Now, the second one is a constant horizontal line, y equals minus 3. From where? From minus 2 on the x, open until 1 closed. That's a horizontal line here. Now, the third one also is a line. It will start from 3, open. See, x greater than 3. You cannot take 4. See, you have to take the 3, but put it open. Because how about 3.1, 3.2, 3.3, 3.4, 3.5? Don't start from 4. You have to start from 3, open. And then you can take another point, 5 or 6 or 7 or 8 or 9 or 10. So this is the graph now. Just look at it. Review it, try it. And then we answer on the next slide. Next slide says where the graph is above the x. See, I made the same graph here, but I changed the colors. Above the x, I made it red here. See, above the x, above the x. This is below. Below means under. See, I made the red one above the x. So I answered the question. This is closed minus 3 to open minus 2. Above the x, that means above the 5. See the 5? 5 is not there. So 5 open to infinity, all this above the x. Domain, you can get it from the question actually. Domain closed minus 3 to minus 2, union minus 2 to 1 closed, and then from 3 open until infinity. The range, the values of the y, this is one value here, minus 3 by itself, and then this one is open at minus 2 until up infinity if you press the graph on the y. Now here we need to solve the inequalities. 2 questions in this one. Question number 24 has part A, part B. Each one can be separate question in the exam. So 3 absolute value this. When you have absolute values, you have to rearrange it first to know which case 2 or case 3. So the absolute value equations and the inequalities all in lecture number 26. Now, when you rearrange this, take minus 6 on the other side becomes 7, divide by 3. Now you're rearranging all absolute value greater than 7 over 3, which is case number 3. This is lecture 26. So you apply it. Remember, to apply it, you have to have or. Remember. So x less than minus c, 2 over 3x minus 1 less than minus c, or the expression greater than c. Now here you multiply by 3 and whatever, rearrange it until x will be less than minus 2. Check it, please. And this one, when you multiply by 3, divide by 2, everything, you get x greater than 5. So the solution between minus infinity to minus 2 union, 5. Please check the numbers here. Now the second one is a little harder. We have absolute value greater than 11 to the power minus 1. The first thing we have to do is there is a condition here, because in the denominator we cannot have 0. See, x cannot be 3 over 2. If you put here 3 over 2, it will be 0. So we cannot accept that. Okay. Now from lecture 4 in the algebra course, I see absolute value of a over b the same as absolute value of a over absolute value of b. So I have to split that. And now I have 1 over a greater than or equal to 1 over b. This is lecture 26. I can take the reciprocal and change the sign. But remember, a should be positive, b should be positive. If you take the reciprocal, you change the sign. So when you simplify everything there, this is what we got. Absolute value 3 minus 2x less than or equal to 11. This is case number 2 from the same lecture 26. This is case number 2. I wrote it for you. absolute value less than is c, then x between minus c and c. So we take the whole expression, 3 minus 2x, between minus 11 and 11, and you have to do it now. How? You subtract 3 there from each one, and then you divide by minus 2, change the sign, then you rewrite it, x between minus 4 closed to 7 closed. Now, if you leave it like this, that's not correct answer. It looks nice, but not correct answer, because 3 over 2 is inside. If it happened 3 over 2 or any number outside, that's the correct solution. So 3 over 2 is inside, we have to take it out from the solution. So how do we remove a number? Make it open. So the final solution will be minus 4 closed until 3 over 2, union 3 over 2 until 7. If f of x is a linear function, that's a linear function, which is algebra course number 30. And f of 2 is equal minus 7. Its graph is passing through the x-intercept of this function. Find f of x. Now, f of x is a linear function. F of x always y. F of 2 is minus 7, so that's x and that's y. And this line, the graph is a line passing through the x-intercept of this. So I take this one and find the x-intercept. You put y0 there. So x-intercept, you put y0 in the second equation here. So what do you get? X equals minus 6. So that's a point on the line. And also, f of 2 is minus 7. That's x is 2 and y minus 7. So I have 2 points now. I can find the slope, which is minus 7 over 8. Because the formula, you know it, y2 minus y1 over x2 minus x1. After you find the slope, you can use this point or this point because both points on the line. So you can try both if you like, guys. Try 2 minus 7 on this x1, y1. Try minus 6 and 0 in x1, y1. You will find the same answer. Now, what do we need? Look at the question here. Find f of x, which is the same as y. So f of x will be minus 7 over 8x minus 21 over 4. Find the values of k if the equation, that's an equation. Now, what do we call it? Quadratic, because x squared has two non-real complex solutions. So he's telling us in the question that the solutions are complex. So what do? You have to think a little. X squared minus kx plus pi equal to 0. This is a quadratic. Anytime you see a quadratic equation, you have to find small a, which is 1, small b minus k, small c here is pi. So now we go to the discriminant. Complex solution means discriminant less than 0. B squared minus 4ac less than 0. Now b squared, the k squared minus 4 pi less than 0. You have to factor this because this is now quadratic inequality, which is lecture 25. See here 25. So we need table of signs. Polynomial inequality needs table of signs, lecture 25. So k minus 2 square root of pi. Now don't say, what is square root of pi? I need calculator, all this. No need, no need. Let me tell you why. Because the zeros here, minus 2 square root of pi and 2 square root of pi. Between them, you can choose a 0. And on this side, between minus infinity and minus 2 square root of pi, you can choose minus 1,000. Here you can choose plus 1,000. And then you choose the solution values of k will be between, because it's negative, minus 2 square root of pi to 2 square root of pi. Find the product of the solutions of this equation. We have seen many equations like this. This is, I think, quadratic in form. So that's lecture 24. Yes, quadratic in form, lecture 24. So we rearrange the equation. Let n be, this power here, 1 over 3, is half the biggest power. If that's the case, if this power is half this power, then you can use let n. Change the variable. This one will be n, this one will be n squared power 2 over 3. So now we have n squared minus n minus 6, simple quadratic. This one we call it quadratic in form. This one we call it quadratic in n. So n plus 3, n minus, n plus 2, n minus 3. Find the n's, back to x. See the 2x minus 1 power 1 over 3 is equal minus 2. Cube, because we have 1 over 3. Cube both sides, x will be minus 7 over 2. Here you also you cube both sides. No need to check here because you have cube root. X will be 14. Find the product, minus 49. Find the domain of each function. I put here 4 of them. So it looks like 4 questions included in question number 28. Some of them are easy, some you have to be careful. Like I can tell you which one is easy. This one is easy. Cube root of 36 minus x squared. Cube root, no fractions, no nothing. Cube root, the index is odd, so domain is R. See, I put all the solutions in one side here, all together. This one is irrational. If you need to see all these domains, you can go to algebra course number 27. So 1 over this cannot be 0. See, there's no radical here. That's irrational. So all real numbers except 0, 1, minus 1. This one you have to take everything radicand greater than 0. That's from algebra course, as I said, 27. Now to solve this, you need table of signs, which is lecture 25. Table of signs, lecture 25. So factor this, make a table. Also this one, 4th root, because the index is even. See, the index here is odd. Index odd, domain R, all real numbers. Here you take the radicand, 36 minus x squared, greater than or equal to 0. Factor it, 6 minus x, 6 plus x. Make table of signs, lecture 25, and you get the answer. Now this one here, we have a nice question. We have the graph is there, and then answer. Domain range, that's 2 questions. Where the graph is below the x, where the graph is above the x, where the graph is above or on the x. Find f of 1, f of minus 1, find x-intercepts. Many questions, 1, 2, 3, 4, 5, 6, 7, 8 parts considered in this question 29. Easily you can go and check the answers here on one slide. So domain is all R because it goes up and down. Range also R. Below the x, see from this number here, from minus infinity until minus 2. Above the x-axis, where the graph above the x? See, you cannot say from minus 2 to infinity. You cannot say that because we need above the x. Above the x, open at minus 2 to open 2. Union open 2 to infinity. Now, if we say where the graph is above or on the x-axis, it will be closed from minus 2 until infinity. It's including all this and also minus 2 and also the 2. So we can ask where the graph is above the x, that's one question, or where the graph is above or on the x. Okay, f of 1 is 1 from the graph, f of minus 1 is 3, you can add. Find the x-intercept, 2 x-intercepts, minus 2, 0, and 2, 0. Now the last one is nice. I said nice because the graph is given, and that's the end of this 30 questions, all the exams review questions. You have to find the function. It is a big story, I know. Find a formula for the function, like find f of x is equal what? Given the graph, you have to do the opposite of the graphing of piecewise. Then you find the domain here from the graph easily. You find the range also easily. Let me tell you what to do. Just take the first piece and then take the second piece separate. This one is a line, you see? So you can take 2 points easy, minus 8 and 1. Take another clear point, let's say minus 4 and 3 or other point. And then find the slope, find the equation of the line. This one is constant. So f of x is equal to 6 between this and this. See, I told you the story now. So minus 8 and 1, so I take this point, clear point you have to take, minus 4 and 3. Then find the slope by the formula, it will be half. Now the equation of the line, use any point and the slope half. You get the function. F of x is equal half x plus 5. But remember, this is a line between -8 and -2. This one closed, this one open, because it's a piecewise. Look at the nice function here. And then f of x is equal to 6 between 3 closed and 7 open. Then you find the domain and you find the range. Remember, in the range, this goes from 1 until 4 open, and there is another number on the y, only 6. So we say union the 6. As I said, this question is the end of the 30 questions. Thank you for watching. If you like the video, please, you can subscribe and share it with your friends. I wish I can see you in another video with another topic. Thank you very much.